Okay, folks, welcome to section 7.2. We're going to get into scale diagrams and reductions this time. So you should find it really similar to what we did before, but instead of making things bigger, we're going to make them smaller. So we've got our original diagram here, we've got our scale diagram. The scale factor equation from the first section is still the same, so just remember that scale factor, if we're looking for it, scale factor is going to be equal to the scaled length divided by the original length. Okay, and the biggest difference, well, the only difference is that now we're doing reduction. So the original is actually going to be the larger length. Okay, so our scale factor is going to be a decimal or a fraction, but when you're doing a reduction, the scale factor is going to wind up being less than 1. Okay, so I've got here a couple of I Love Math buttons that I knew you guys would enjoy. And if we look at the dimensions on these, I'm just going to note the diameter. Okay, so from here over to here on the original, and from here over to here on the reduction. So on my screen, the original one, this is about, and I'm just going to use inches just to show you the units don't matter. So this is about 4 inches on my screen. And on the scale diagram, the reduction, it's about 2.5 inches, so 2.5 inches. So those are our diameters. All right, so diameter and diameter. Okay, so to do our scale factor, just like we did before, it's going to be the scaled length divided by the original length. This time the scaled length is the smaller number, and that is where this tends to get tricky. You've got to remember, for a reduction, the scaled length is going to be the smaller number. So that's going to be 2.5 over inches divided by 4 inches. Okay, so 2.5 divided by 4, grab a calculator, and that's going to be 0.625. All right, and again, just like before, inches are going to cancel inches, and our scale factor is going to be 0.625. Okay. If we were to look at using that scale factor, so just remember we're going from the original to the scale diagram. If I took a feature of the original, so I'm going to take the letter I. All right, so on my diagram, the letter I is, actually I'll measure it in centimeters. It's about 1.8. The letter I on this is about 1.8 centimeters. Okay, let me just switch colors so you can see what I'm up to here. So this height, and again, I told you the units don't matter, but whatever units we start with are the units we will get, is about 1.8 centimeters. So if I'm going from the original to the scale diagram, what we would do is exactly like before. We would scale this to get over here by our scale factor, and our scale factor, 0.625. So 0.625. If I take 1.8 centimeters, multiply it by the scale factor, 0.625, I will get 1.125. Okay, 1.125. And since this is centimeters, this will also be centimeters. Okay, so I'm going to check that probably with my ruler. Hopefully it'll be about 1.1. And yeah, it is. With I know you can't see me doing that, but when I put a ruler up to my screen, that's about 1.1 centimeters tall for the eye on the little one. Right? So about 1.1, I'll put in the rest, 25 centimeters. Okay, again, very, very similar to the last unit. The biggest difference is that this is the decimal. The other tricky part that you're going to see sometimes is we're going to be writing these as fractions and working with them as fractions, and you'll see that a little bit in the next section or in some of the next examples. Okay. All right. So here we've got Scale diagram of an octagon. So I know it's not what you'd probably pictured for an octagon. All that means is that it has 8 sides. We have 6 centimeters, 2, 4 centimeters, 2 centimeters, 4, 2, and 6. So our 3 lengths are 6, 4, and 2. All of the sides are either 6, 4, and 2. And we're going to draw a scale diagram of this applying a scale factor of 0.25. So what that means, just like before, to scale this, we're going to take all of those sides and we're going to scale them by 0.25. And if we do that, we will get something like this. We take our 0.25 times 2 centimeters, it gives us 0.5. 0.25 times 4 is 1, and 0.25 times 6 is 1.5. So corresponding sides on the scale diagram are going to scale as follows. The 2 centimeter sides, these guys, will go to 0.5. The 4 centimeter sides will all go to 1, and the 6 centimeter sides will all go to 1.5. Okay, and it'll look something like this. All right, so in terms of corresponding sides, these ones were all 6, and those are now all 1.5. These guys, the 2s, all scaled to 0.5. And last but not least, the 4s all scaled to 1 centimeter. All right, so that's how that would work on the diagram. So again, this time we're getting a reduction, so your scale diagram is smaller than the original. Okay, when we work with these, sometimes scale factors for reductions are given as a ratio form. Okay, so here's a blueprint of an apartment, and it says the following floor plan for the apartment is a 1 to 40 scaled down version of the actual dimensions. So what does that mean? Well, it means a couple of things. It means that the original measurements as given here are 40 times bigger than the diagram measurements. Okay, so if we were going to scale up, if you measured on the diagram, you should be able to scale it up by multiplying by 40. In that case, we'd be thinking of the diagram as the original and the actual apartment as the scaled version. Okay, and that's not really accurate, right? Like the diagram is a scaled version of the apartment, so it's got to be smaller. So if our scale factor is given like this, if our scale factor, oh, I don't want that color. If our scale factor is given as 1 to 40, then what we can do with that is we can change it to a decimal. So it's a 1 to 40 ratio. This is a part to whole ratio, so that's the same as 1/40th. And 1/40th, if I do the division, 1 divided by 40, is 0.025. So 0.025. So if you get a scale factor given as a ratio like that, you've got to go from ratio to fraction. And then you take your fraction and divide it out, and then that takes you, if you want, to your decimal. Okay, so again, you just treat your fraction as a division, and that gets you your decimal. So 1 over 40 is 1 divided by 40. And now I can take a look at the question. It says use the scale factor to determine the dimensions of the living room. So here's our living room, living dining room. I guess I should have said living room / dining room. And it's 3.85 meters by 3.8 meters. So that's the actual. So these measurements, and I know it's on the scale diagram, but these are going to be our actual measurements. So these are the original measurements. Original measurements. And all that we're going to do is use our scale factor with our original measurements to get the measurements that would be on the floor plan. Okay, if it was a truly scaled down version. So on the floor plan, that 3.85 meters is going to get scaled by 0.025. And the 3.8 meters is also going to get scaled by 0.025. Okay, so this is the original. This is times the scale factor. I can fix that. And then this is going to be the actual size, or the size that it would appear on the piece of paper that would be your floor plan. So this will be the scale diagram. All right, so if I take 3.85 meters, multiply that by 0.025, then that's 0.09625. And we're not going to round, okay? 0.09625. And since this is meters, this is also going to be meters. And then for the 3.8, then that is 0.095. I probably should have picked a room that wasn't quite as square as this one. So, but I didn't. So we'll work with it. 0.095 meters. All right. And to put that in perspective, because these numbers might not mean quite as much to you, remember that, I'll write this over here, 1 meter is 100 centimeters. So to go from meters to centimeters, the number part, we multiply by 100. So if I take these and I multiply them by 100, I get that this is, so times 100, the decimal would move over 2 spots. On the diagram, this would be about 9.625 centimeters, and this one would be 9.5 centimeters. Okay, just to put that into perspective, if you're looking at it on a piece of paper, these numbers, these are the correct numbers, because meters have to transfer to meters, and meters transfer to meters when we apply our scale factor. But that'd be, you know, not quite 10 centimeters by 10 centimeters if you were looking at it on a piece of paper. Okay. All right. So one more. And so here we're going to go backwards. We've got a truck. So this is a model truck. It's a die-cast model of a 1953 Ford F100 pickup. And they've given the dimensions. So this is straight off the website where I found this for sale. I can't remember how much it cost if anybody's interested. And we're saying that it's a 5:90 scale. So again, the scale factor is given as a ratio, 5:90. So this means that on the model, 5 units on the model, so I'm going to say on the scale, would correspond to 90 units on the original. Okay, so it's getting scaled up, 5 units on this, so 5 centimeters on this guy would be 90 centimeters on the original is what that ratio is saying. So it says express the scale factor as a fraction in lowest terms, which I know you're going to love, but your book does ask you to do this a little bit, so I wanted to do one. And also as a decimal. The decimal is going to be much, much easier. So if we start in here on question A, change my colors, our scale factor, as given, is 5:90. So 5:90. And remember, that's our ratio. So as a fraction, we're going to turn that sideways. It's a part-to-whole ratio, so it would be 5/90. And you might recognize that these numbers are both divisible by 5. So to get our fraction in lowest terms, we can divide. 5 divided by 5 is 1. And 90 divided by 5, I'm just going to note that I'm dividing by 5. 90 divided by 5 is going to be 18. Okay, so divide by 5 to put it in lowest terms. So it's going to be 1/18. All right, so that is our scale factor. It's 1/18 as a fraction in lowest terms. And if we want it as a decimal, I'm just going to take 1, hold on there. I'm going to take 1 and divide it by 18. And my scale factor is 0.0555 repeating. All right, so here's my fraction in lowest terms, and as a decimal, that's 0.05 repeating. Okay, so 5:90 equals 1/18, fraction in lowest terms here, and then as a repeating decimal, or as a decimal, 0.05555555, or 0.05 repeating. Now in this case, we're going to go, we've got this scale factor that we've now put in lowest terms. So remember, 5:90 is the same as, so the ratio scale is the same as the fraction, right? We divide top and we divide both numbers by 5, and we get that it's 1 to 18. So, and here's where it gets a little bit kind of weird. Rather than thinking of this, because now we're scaling to the actual truck. So the actual truck is bigger, obviously, than the model. And 1 unit on the model is going to be 18 units on the actual truck. So what we can do is we can treat this, and again, this is where it does get a little bit weird when we're going backwards. We can treat this as if the model is the original, so, and the actual truck is going to be our scaled up version of the model. Okay, and if it's 1 to 18, model and actual, then we take our model dimensions, which were 10.5 inches, 4 inches, and 3.75 inches, and we scale them up by a factor of 18. Okay, and I hope I haven't made that more complicated than it needed to be. This is the scale factor to go from the original truck down to the model. But if we're trying to go the other way, if this is a 1 to 18 scale, and our scale factor is 1/18th, then we just kind of flip it. We take the inverse, or the reciprocal, sorry, and we're going to take the model and we're going to scale all of these lengths by 18. And again, I told you in the first section it was relatively straightforward, but it got trickier. This is where it starts to get trickier. Okay, we're going to scale this up by a factor of 18. So if I take 10.5 inches, multiply that by 18, on the model, on the actual truck, that would be 189 inches. 4 by 18, so that would be the width. So that would be 72 inches wide. And 72 inches, just while I'm here, that's about 6 feet. Right, so 72 inches, about 6 feet wide, which is, it seems a little, I don't know if that's wide or not. It's about right, I guess. And then the last one, 3.75, if I scale that by 18, I get 67.5. So 67.5 inches, and that would be the height. Okay, so again, this was the length, the width, and the height. And I guess that makes sense because the truck would be 67.5 inches. That's the top of my head would be just over the top of the truck, right? That's 5 feet 7.5 inches. So this is one way to work with these. Note that if we wanted to apply the scale factor, like treat this the other way around, where the actual truck is our original and this is the model, then we'd take each of these numbers and we'd multiply by 0.55555 or by 1/18th to go backwards. All right, so let's take a quick look at the practice ones that I'm gonna give you guys in class. I'm not gonna do all of these on here. I'll go over them all in class after I've given you guys a chance to work on them when we do our Zoom or our Google Meet. But for here, I'm just gonna kind of hit the highlights. Express each fraction in simplest form and then express it as a decimal. So these are meant to represent scale factors. So the first one is 25 over 1,000. So we have 25 over 1,000. What I would do to put it in lowest terms is probably, I believe 1,000 is divisible by 25. I'd divide them both by 25. So if I divide by 25 and divide by 25, 25 divided by 25 is 1, and 1,000 divided by 25 is going to be 40, I believe. Okay, I'm just going to double check that. 1,000 divided by 25, because it's early when I'm recording this. Yeah, 40. So as a fraction in lowest terms, this would be 1 to 40. And if I want the decimal, I can do two things. I can take 25 and divide it by 1,000. And if I do that, 25 divided by 1,000, 0.025. Or I also could have done 1 divided by 40, and that should also give me 0.025. Okay, so that is number 4, part A. And these ones will follow. Divide top and bottom by 5, divide top and bottom by 2 to put it in lowest terms, and divide top and bottom by 3 to put it in lowest terms. That'll give you your lowest terms fraction. And then to get the decimal, we just do it as a division. 5 divided by 125, 2 divided by 1,000, and 3 divided by 180. All right, so now on to these two. Here we're looking for a scale factor. And remember, when you do your scale factor, I'm just going to switch colors, the scale factor equation, so this is going to be for number 5, your scale factor is always the original on the bottom. So in this case, it's going to be the scaled divided by the original. And that hasn't changed. What has changed is that now the scaled, and this is the reduction, that is our scale diagram, is smaller than the original. So we're scaling down, we're not scaling up, but the original still goes on the bottom in your formula. So for this one, I'm going to look at this side. This is 1 unit tall on the reduction. And on the original, it's 1, 2, 3, 4, 5 units tall. So my scale factor would be 1 unit divided by 5 units. If I wanted to write that as a fraction, well, it's 1/5. And if I wanted it as a decimal, 1 divided by 5 is 0.2. Okay, so that is the scale factor for 5A. For 5B, again, they've given us the measurements, which is kind of nice. For 5B, your scale factor is still the scale diagram on top. So the 3 would go on top, because that's our scaled, divided by our original. So it would be 3 centimeters, sorry, forgot the units, divided by 4 centimeters. And remember, the units have to be the same. So centimeters divided by centimeters. So as a fraction, that's 3/4 if you want. Centimeters will basically cancel. Centimeters per centimeter go away. And if you want it as a decimal, 3 divided by 4 is 0.75. Okay? All right, so that is how those ones work. But then the biggest, and I know I keep stressing this, but it's because it's the part students tend to miss. We're happier blowing things up, making them bigger, than we are making them smaller usually. But in this case, the smaller number is the scaled, and it goes on top in our equation. So now, for these guys, number 6, for each pair of circles, the original diameter and the diameter of the reduction are given. So this is basically the same thing we just did, but they haven't given us diagrams, they've given us dimensions. Determine the scale factor as a fraction or a decimal, sorry. So I'll do both, and I'm only going to do A. All right, so for 6A, our scale factor again is going to be the scaled length divided by the original. Okay, so just remember that. The original always goes on the bottom. So in this case, this is going to be our original. They're saying this is the actual circle and this is the reduction, so this is our scaled. All right, so original is 50 and the scaled is 30 centimeters, so the scale factor would be 30 centimeters over the original length, which would be 50 centimeters. And if we divided that out, centimeters will go away, centimeters per centimeter will just go away. And 30 over 50 as a fraction, I'm hoping you can see, we divide them both by 10, that would be 3/5. And if you wanted it as a decimal, you could have just started and done 30 divide 50, right? So top divided by the bottom, 30 divided by 50 is going to be 0.6. Okay, so the scale factor here would be 0.6. And the others are going to follow. The only place that you've got to worry is going to be, remember, when you get to these last two, we got meters and centimeters, we got kilometers and meters. When you get to these last two, you've got to change them so that they're in the same units. So you can use the Google trick that I showed you before, or you can use your own general knowledge of the units. The connection I'll give you, just remember we have centimeters and meters. So for D, 1 meter is 100 centimeters. And for E, we've got kilometers and meters. So a kilometer, kilo, means 1,000. So 1 kilometer is 1,000 meters. Okay, so hopefully that'll help you when you get to those two. You got to put them into the same units. Yeah, and that's all I've got. The video is almost 25 minutes, so I will call it quits, and I'll see you folks in class. And if you have questions, as always, get a hold of me by email. If you're working on these and you post a private comment in your assignment, I get an email immediately, and during your block I'll be watching my email, so you shouldn't have to wait long for an answer if you're having trouble. All right, talk to you later. Bye.